All right. Here is a quick review of the 4.3 to 4.4 practice quiz, which will greatly help you on your test on Wednesday. All right, so let's get started. I'm going to move a little quickly here because, you can pause and rewind, so on and so forth. So here is the key, and here we go. I have students in here, advanced pre-cal students in here, so hopefully they're not too noisy and you can hear all right. All right, so these are just derivatives. Find dy dx. Okay, this is going to be the product rule because you can see two functions there being multiplied. All right, so we're going to differentiate 2x to 2, leave e to the x squared alone, and then we're going to add 2x left alone and differentiate e to the x squared, which is just e to the x squared times the chain. All right, with the e's, we usually factor out 2ex squared if you can, or whatever you can factor out, factor that out. That leaves me with 1, and then we've got the 2 here and this out, so that leaves me with 2x squared. Okay, and that is the 4 points that you need for number 1. Okay, next problem is number 2 here, a derivative of an inverse. Okay, so f prime here, the 5 can just be scaled out, and then we're going to multiply it by the formula for inverse sine, 1 minus this 3x squared, quantity squared times the chain of 6x. All right, so that leaves me with 30x up top. And then on the bottom is simply 1 minus 9x to the 4th. Get that a little closer for you guys. Okay, and maybe zoom it in. All right, so that's number 2. Number 3 then is y prime. We've got a natural logarithm, so that's just 1 over that argument and then a chain. So 1 over 2 root 2 minus x, and the chain is negative 1. As I'm talking, they're just getting noisier and noisier in here. Okay, so this will just be 2, and then the square will just be 2 minus x squared. Or sorry, 2 minus x. 4 minus 2x there. All right, so let's just box these. And I'm going to pause for a minute and see if these guys can quiet down a little bit. So I'll be right back. Okay, I'm back. All right, so this is a second derivative here. So first derivative, make sure you guys can see. First derivative, and this is inverse tangent, is going to be 1 over 1 plus 2x squared, quantity squared that is, and then of course the chain of 2. All right. So the first derivative, to save room, I'll just put over here, is going to be 2, and then 1 plus 4x squared. Okay, but we have to do the second derivative, so we're going to do that. And instead of the quotient rule, I think I'm going to use the product rule and just bring 1 plus 4x squared up and make it negative 1. Actually, I don't need the product rule. Sorry, I'm going to use the power rule. I'm going to bring that up and use the power rule with the chain. That's not a function, so it won't be the product rule. All right, so here we go. That just is going to become negative 2, 1 plus 4x squared, negative 2, and then we have a chain of, it looks like 8x. All right, so this final answer then would be, looks like negative 16x on the top, and then this can go back down to the bottom. Okay, so negative 16x, 1 plus 4x squared, quantity squared. All right, couple more derivatives. So this is a base of 3 and then an exponent, so we're just going to leave that alone. We're going to use our exponential rule. Just leave that alone as if we do, oh, you can't see. Oh, no, you can't see. Just leave that alone as if it's e to the x, but you get ln of the base. And then we're going to take the derivative of the chain, which is ln of x. So that is really it right here on that one. That's about as far as this problem can go. 3 ln of x times ln of 3 over x. All right, here is the last derivative in this first section. First derivative of log base 3 of pi x to the 4th. Okay, so this is going to be kind of like ln. It's just going to be 1 over this argument, right? Except you get ln of the base here. And then, of course, the chain, which is just 4 pi x cubed. All right, so we get some cancellations there, which is nice. Pi cancels, 3 of these cancel, and that's it. So 4 over x ln of 3 is our last derivative. Okay, let's see what's going on here. These are inverses, and f is here. Find g prime of the inverse. Okay, so remember this from class. This is 5 points. The first thing we needed to find here was something that gives us, an output of -5. And like I promised, it'll be something easy to find, not something super obnoxious. So if you just test f of 1, you're going to get 1 cubed minus 3 times 1 squared minus 3, which of course is 1 minus 6, which is our -5. So that's awesome. We needed that. So that's the first thing you want to find. Okay? And so we've got this point 1, -5 for f. All right, so next thing we're going to do is derive the formula for composition. And we're looking for g prime, so we want that to be the inside function. And we know the property says it's x. Let's take the derivative, so f prime, leave g alone, and then times the chain. That's 1, and so when we're looking for g prime of x, we'll look at 1 over f prime of g of x. Okay. So with that being said, let's go ahead and find g prime of -5 like it s. Okay, so that'll be 1 over f prime of g of -5. Okay, well, g of -5 will be the flip of this. If f of 1 is -5, g of -5 will be this 1. Okay, so now we're looking for 1 over the derivative of f at 1. So the next bullet point I'll have to do is take that derivative. So I'll just do this over here. F prime of x is 3x squared minus 6x. So I'm just going right here, 3x squared minus 6x. And if I put 1 in there, I get 3 minus 6. So that's -3. And that's what I'm going to pop right here for f prime of 1. So this answer is 1 over -3. All right. Next question on the front. Again, this is going to help you greatly on the test on Wednesday. Particle moves along the x-axis, so its position at any time greater than 0 is given by s of t. Velocity at the indicated value, first derivative. So v of t is, leave it alone, and chain. Okay, let's plug 5 in. E to the 1 times 1 over 5. So v of 5 is e over 5. And doesn't look like we have any units there, so we'll just leave it at that. Of course, if there were units, it would be the linear over the time, so meters per second, etc. At t equal to 5 is the particle moving towards or the origin or away from the origin, and is it speeding up and down? Okay, so I want to analyze v of t on both, and for towards or away, s of t, and for speeding up or speeding down, acceleration. Okay, so let's go ahead and do towards. So v of 5 is e over 5. Okay, so that's 2.718 over 5. That is positive. So it's moving in a positive direction. and let's see what its position is. Its position is e to the 5 over 5, which is e to the 1, which is also greater than 0. So it's starting to the right of the origin, starting somewhere over here, and moving in a positive direction. So this is away. Okay, and I would just say, you can just explain it that S of 5 is greater than 0, and I put a plus sign and then ND. And V of 5 is greater than 0. So it's moving in a positive direction from a positive position. That's away from the origin. Okay, and so here we've got V of 5 is greater than 0. We've established that. We need to get A of t, which is just going to be the derivative here of this velocity, which is, velocity function is right here. 1/5 t e to the t over 5. So this 1/5 will just be a scalar. E to the t over 5 will just stay, and then a chain. All right. So A of 5 will be 1 over 25 times e to the first, which is positive. So they're both positive, same sign. A and right up here have the same sign. So speeding up. Okay. All right, let's move to the back. Use a table, all right? I like the tables. I'm almost done here. So this is another one of those inverse ones. G prime of 3 is what we want to find. So let's do that derivation. That's the inside. We want that to be the inside function. So f of g of x equals f prime equals x. Move downwards. Okay, so f prime of g of x equals g prime of x equals 1. All right, so g prime of x equals this 1 over f prime g of x. Okay, so this is g prime of 3, so I need to find something 3 on f. Okay, so an output of 3 of f comes from 2. So on f, 2 yields 3. So that means g of 3 will be 1 f prime of g of 2. Okay? So if that's on f, then on g is 3, 2. Okay, so sorry, I got ahead of myself. That's 3. All right, because you're just plugging that in. We got to go here to g prime of 3 is then 1 over f prime of here, 3, 2, right? The flip of this. And then we just got to pick up f prime of 2. So f prime of 2 looks like 1. F prime of 2 looks like 1. Okay, so this is just going to be equal to 1 when all is said and done. Okay, going to find the second derivative here implicitly. 18x, okay, that's just pretty easy. 18x, and then 2y dy dx. And that is equal to 0. So 2y dy dx is equal to negative 18x. So dy dx is equal to negative 18x over 2y. All right, so the second derivative then is going to involve the quotient rule, differentiating second derivative with respect to x twice. All right, low d high minus high d low, that gets a dy dx. Okay, over low squared. All right, so let's check this out. All right, let's check this out. This is going to be, I guess I could have reduced here, huh? This is negative 9x over y, but we can just make our reduction here. Okay, so this will be negative 36y plus 36x dy dx over 4y squared. Let's reduce everything by 4. Negative 9y plus 9x dy dx, and then over y squared. And then we just sub in what dy dx is equal to in for dy dx. So it should be negative 9y plus 9x over y squared, and then this would be times negative 9x over y. All right. So it looks like for a final, we're going to get negative, if this goes in, or sorry, positive, I don't know, let's see, let's get y cubed on the bottom. So let's do negative 81x squared minus plus 81x. Okay, sorry, my bad, I had to erase. This is strictly in the numerator, sorry. End of the day, I'm tired. Alright, so let's do baby fractions to deal with this, because this is going to be a complex fraction up here. Okay, so baby fractions, we'll just do y over y, and this is going to get me negative 9y squared plus, that'll be minus 81, that'll cancel there, it'll distribute over here, and cancel there, so minus 81x squared over y cubed. Okay, that looks like it's done then. And then there's that final piece where if you can make a substitution, you sort of maybe want to. So just take a look up and look at y squared. It's equal to 9 minus 9x squared. Okay? And so let's just see if that substitution helps us. Negative 9 times 9x squared. Or sorry, 9 minus, negative 9 minus 9 minus 9x squared. And that's just going in right here. Minus 81x squared over y cubed. All right, so that'll be negative 81 plus 81x squared. So it does benefit us because we get this additive inverse, and the most simplified answer would be for the second derivative. I'm just going to write double prime there. Would be negative 81 over y cubed. Okay, and then the bonus right here. Okay, so this is going to need logarithmic differentiation. All right, so when I see this x, both of these having an x, that's going to be logarithmic differentiation coming into play. So first, let's just take the ln of both sides. Okay, not doing calculus yet. We're just pulling the secant down. So ln of y will equal secant. I'm going to take the ln of this. It's just going to pull that secant down. All right, so we'll pull that secant down in front. Can you guys see? Yeah, secant x. Oh gosh, jeez. All right, secant x times ln of x. I'm not redoing the video because of that. Okay, so let's differentiate. This will be 1 over y dy dx. Okay, and then we're going to need the product rule here. Okay, but luckily there's no dy dx on this side, so we'll just do secant of x, which is going to be secant tan ln of x, and then plus secant x over x. Okay, so really not a lot to simplify here. Maybe let's send the y over. It'll multiply up to the other side. It'll multiply up to the other side, okay? So y will be right there. And then we could pull maybe a secant out. And we would be left with tan of x ln of x plus 1 over x. And then we replace the y with the original problem. And that's just x secant x times the secant x factored out. And then in that parentheses, I'm just going to write it down here for room, tan of x times ln of x plus 1 over x. All right, so there is the bonus problem. Okay, so hopefully that helps you with the practice quiz that you worked on Friday, and will eventually help you on the test on Wednesday. All right, see you guys next time.